My name's Andre Kemp-Upton. I've been an architecture designer for 38 years, and I enjoy doing renovations and design renovations, and have got blisters from doing them myself. My sons are builders and I've done many myself. Especially in New Zealand at the moment, I look at the stock that we have, which is grossly underperforming, and if we want to create healthy homes in New Zealand, we have to look at that stock level, not just our new homes that we're building each year. And it seems like a low-hanging fruit to me as to how can we improve the performance of that low-hanging fruit. It would be being able to measure the performance of buildings and the exterior envelope of a building. So that's to do with how to measure air movement, quality air recovery systems, insulation. So most of the things relating to the envelope of the building are what create a healthy home.
Air tightness.
Air tightness, ventilation.
Air quality.
Build it tight, build it right.
Yeah. So I think, measuring, modelling is what you're talking about, isn't it? So
yeah, it is.
Modelling. But if it's not an existing building, you can't monitor it, so you've got to model it.
Correct.
Guess,
yeah. There's no point trying to add things later when you're halfway through a build.
Yeah.
Doing the modelling up front when your designer or can visit the site, have a look at the detailing, and say this is the problem we have with this building. This is why it's potentially not going to perform. If we look at these particular details, we can drastically improve the performance of the building.
Yeah, and it's verifying the performance for certification or ratings at the other end of the project, isn't it? So that's probably where most of the modelling happens currently.
Correct. So some people or some systems spend a lot of time modelling in order to look for a certification. Whereas if you didn't do that and you just did some design modelling at the beginning and spent that money on certification on a high performance heat recovery ventilation system, perhaps, then you'd get a better outcome.
Yeah. So my understanding of modelling is it's telling you how good or how bad the building is. It's not necessarily telling you how to make it better or worse, but it might be setting you on the right path.
Correct, that's right. Yeah. So if you know that you've got a leaky roof system where it's leaking a lot of air, like the example you spoke of earlier where there was a TNG floor and they put a plywood over the top of it and then tape it off, then knowing where your leaks are is where you put your silicone. It's a bad example because nobody wants to use silicone, of course, but how to stop
or your tape.
Or your tape.
And there's that, even the scientists say it's sort of garbage in, garbage out. It depends on the quality of the data.
Well, it
probably depends a little bit on what tool you're using, what software you're using as well.
That's right. And you're right. So how do you make a decision on where to best spend your dollars? Because everybody has limited funds when they're doing renovations, especially. Then where you put those funds to get the best performance out of them, you can sometimes make a decision on air leak, mechanical ventilation, window performance, and those sort of things. So if you've only got which thing do I need to do now that I can't later, I can do later.
Yeah, and with renovations, you've got less things available that you're able to change because you can't change the orientation.
That's right.
You could probably change some of the windows and make bigger windows or smaller windows.
Yeah. And as we know, when it comes to solar cooling, to get better performance out of buildings, you can provide shrouds and things you can add
shading,
onto a building. So shading devices in order to keep cooling to a problem, because we tend to think about homes being cold and damp, which they are, but being hot and damp is just as bad. So
New Zealand, it's probably less up here in Auckland. It's good sort of 5-7 degrees warmer, but down on the South Island, it's sort of predominantly a heating climate. So that means sort of 80-90% of the time you're heating.
Yes, that's right. Well, and the irony in Auckland is where people don't sort of get on the same bandwagon around building performance is that it's warm enough here. We live in a temperate climate, but it's 82% humidity inside and outside. So any moisture you've got inside the building, you can't make work.
Yeah. I think measuring is great. This renovation that we were talking about earlier, the first thing we did is we went around and we just recorded what the temperature was inside and what the temperatures were on the surfaces. Dan's going to do the blower door test, have a look at it with a thermal camera. Just do a real thorough analysis of it.
Yeah.
And then we've put sensors in there too. So we've got these little Monkeytronic sensors in a couple of the rooms.
Yeah.
So we can have a before and after, what is it like in the middle of winter before we renovate it? What is it like next winter after it's been renovated?
Yeah.
So-
So doing your blower tours, you can see where the leaks are potentially straight away.
I can tell you where all the leaks are.
All those
Through
vents and
the
then
vents.
walk
Point them out
Yeah,
to you.
I mean they're
Down
obvious,
there.
aren't they? Yeah.
Yeah.
So
So,
sticking
again,
some
you know-
duct tape over those and seeing how the blower door test changes. We know where we've got to fix it again.
Yeah, with there's so much to learn by measuring with before and after with a renovation. It's even more kind of clear.
Yeah, well, I
where
think-
you need to make interventions.
Correct, and that's where having some education around the design stage is really important. So making sure that your designer and your builder team are talking to the client about what are your expectations, and is there a budget and where do you want to spend it? Is then being able to pinpoint the gaping holes in the envelope, or is really, I think, the best, most important way of focusing your attention.
And yeah, the next big thing that we're up to our eyeballs in at the moment is measuring carbon.
Yes, that's another whole game, isn't it?
It's very true.
So that's a real steep learning curve and quite a challenge. But once we've done it, we're doing New Zealand's first carbon negative super home.
Oh,
Once we've done it once, the second one will be easy. It's like
Yeah.
anything for the first time.
That's
It's
right.
hard the first time.
That's right, like the first 10-star home.
You'll know all of the decisions to make around the right materials and things. The carbon, low carbon, or the carbon sequestering even.
That's right. Well, I think that when you look at trying to even going back to retrofit or renovating again, is that the embodied carbon that's already in the home that you're not demolishing to take change for another one is important.
Yep.
But also the amount of energy that you're losing by having a home that's too cold is important as well, because if you've got a low performing home, it's going to have a higher carbon footprint than if you improve it to, like you're saying, that example you mentioned, that the home is now performing much better, then it's lower carbon footprint.